So, hello InformNet students. I'm going to show some examples on how to do neutralization problems. The notes in the lesson mainly use the C1V1 C2V2 formula, so looking at moles of acid equaling moles of base. Another way to do that is using stoichiometry, which is actually shown as well in the notes. Either way is perfectly acceptable. The curriculum focuses more on the stoichiometry method, and I feel like it relates a lot more to what you did in grade 11. So that's the method I teach with my classes. Feel free to use either method if the mole acid, mole base, like moles of H, moles of OH method makes more sense to you. Go for it. I find that more students tend to like this method a little bit better. So I'll show you what I mean. We're basically just doing stoichiometry like we did in grade 11. So in order to do stoichiometry, there's a few steps we have to follow. We always write the balance equation. We have to convert whatever we're given into moles, and we use the mole ratio to find the moles of what we're looking for, and then we convert to whatever units we're being asked for in the question. Now, again, like I said, both methods are perfectly acceptable. In essence, what we're doing is moles of acid equals moles of base in both methods. It's really the same calculations. It's just two different ways of looking at it. So let's just do a few examples and you'll see what I mean. So here's an example. We have drain cleaner, NaOH, and we're reacting with HCl. So HCl is reacting with NaOH. This is our stereotypical acid-base reaction. We're making literally salt, NaCl, table salt, and water. Now, the nice thing about this reaction is that because HCl is a monoproduct acid, one proton, and NaOH is a monohydrotic, one hydroxide base, it's a 1-to-1 ratio. So we really don't have any mole ratios here. Something that I tell my students to do is to write the information down, like pull the information out of the question and organize it so it's doesn't look so messy. What we have is 35.0 liters of drain cleaner, or milliliters I should say, milliliters of drain cleaner, and we have 50.08 mils and 0.409 moles per liter of HCl. So what we're going to do is we're going to take whichever one we can find moles of, and we're going to do that because we want moles of acid and moles of base. And during the stoichiometry method, we don't have to worry about how many H's and how many OH's because we would do that when they're balancing the reaction. Anyways, so I need to find moles per liter of NaOH. In order to do that, I need to know moles and liters. I actually already know liters, so we just need to find moles. So what I'm going to do is I'm going to take the information I have here and find the moles of HCl, which will allow me to find the moles of NaOH, which then I can find the moles per liter. So I'm going to start with my volume, which is 0.05008 liters. I've just divided by 1,000, timesing by moles and dividing by liters, so I can cancel out the unit liters. We have from the question 0.409 moles for every 1 liter. So when we do that math, 0.05008 times 0.409, we get 0.0205. And that would be your moles of HCl. So now what we want to do is we want to find the moles of NaOH. So I'm going to use the reaction to do that. Moles of NaOH, so 1-to-1 ratio for moles of NaOH to moles of HCl. So 1 mole per 1 mole. So that means that we're going to have 0.0205 moles of NaOH. Now the question wanted us to find moles per liter, and we have moles and we have liters, so we need to make it look like moles per liter. That line just means to divide by liters. So I'm going to divide by 35 mils or 0.035 liters, and we get an answer of 0.585 moles per liter of NaOH. And there's your final answer. Now again, you could do the C1V1, C2V2, like I guess CH, VH, COH, VOH formula, and there's nothing wrong with that. You just really have to watch out if you have more than one H or more than one OH because it affects your moles of H's and OH's. So when we get to something like this where you definitely have a polyhydrotic base or a polyprotic acid, that's going to affect things. So again, same thing for stoichiometry method. I'm just going to write my balanced reaction. So BaOH2 here is reacting with HClO4. So BA has to go with ClO4, which is a 1-, so BaClO4 2, and then H2O. Got to go back and balance everything, so I'm going to need a 2 here to balance, which means now I need 2 in front of water. Now I'm going to write my information underneath again, 0.256 moles per liter, and this is 0.0, I'll just change it to liters right now, 0.046 liters, 0.407 moles per liter. So now I'm going to find the, what do they want, the volume. So the liters. If I find the moles of BaOH2, then I can cancel out moles and get liters. So I don't know the moles yet, but I can find the moles of HClO4. And that's what I'm going to start with. So I have 0.046 liters, and I want to get rid of liters, so I'm going to put them in the bottom, moles in the top. We know from the question that 0.407 moles for every 1 liter. So 0.046 times 0.407. is 0.0187, and that's moles of HClO4. So now we want to use that and the ratio to get to moles of BaOH2. So moles of BaOH2 on the top, moles of HClO4 on the bottom, and it is a 1:2 ratio. So I'm going to divide this answer by 2. And I get 0.009, I'm going to round it off to 94 moles of BaOH2. Now at this point, we know the moles, and we also know the moles per liter, so I'm going to cancel out liters. So how do I do that? Or sorry, I'm going to cancel out moles, to get liters. I want to put moles down here, and I want to put liters here. 0.256 moles per liter is the same thing as 0.256 moles per liter. I can just flip it over, so 1 liter is 0.256 moles. And I'm just going to answer it down here, I'm going to divide by 0.256. And I get an answer of 0.037 liters. And that basically means 37 milliliters. Right, that's the process anyways. There's a couple, try these ones. If you want to pause the video, give them a shot. Like, here's the question, give it a try. Then resume the video and see how you did against my answer. I'll just start right now. So sulfuric acid is H2SO4. And sodium hydroxide is NaOH, and so this is going to be making Na2SO4 and H2O. Have to go back and balance. 2 there, 2 there. So this is 0.1. This is 0.1 moles per liter, and this is 10 grams. So from the question, we don't know. We want to know the volume of this. We don't know anything else except for the grams of your base. So using the grams of the base, 10 grams of NaOH, we can actually find moles. We know that 1 mole of NaOH weighs 40.01 grams, that's its molar mass. So this ends up being 0.25 moles of NaOH. Now that we have the moles of NaOH, we're going to find the moles of H2SO4, and it's a 1:2 ratio. Moles of Na. Try this again. Moles of NaOH. So 0.25 divided by 2 is 0.125. So that's 0.125 moles of H2SO4. Now at this point we have the moles per liter. So I want to get rid of moles. Moles got to go on the bottom and liters on top. So we know the moles per 1 liter is 0.1. So I'm taking my answer and divide by 0.1, and the answer is 1.25 liters of H2SO4. All right, last one. So we have the molarity of this magnesium hydroxide reacting with phosphoric acid. So this is B1, where if you're doing C1V1, C2V2, we really have to watch out because we have a polyhydroxic acid, base and polyprotic acid. So we really have to watch out, because when you find that when these concentrations you have are not the concentrations of your H's or OH's, they're the concentration of the actual entire acid or base. So you got to take into account the number of H's and OH's. Using the stoichiometry, you actually do that by using the ratio from the reaction. So this is what the reaction would look like. You have MgOH2 reacting with phosphoric acid, which is H3PO4, and you're going to make Mg3PO4 and H2O. So we have to actually go back and balance all of this. I need 3 magnesiums there, and I need 2 phosphates there, which means I end up needing 6 waters over here. So what you notice is actually we account for the stoichiometry, or the number of H ions and OH ions, using the stoichiometry. So our mole ratio takes that into account. But if you're doing the concentration of H and OH, it doesn't. So you have to remember that step, and most students don't, which is why I like the stoichiometry method a little bit better. Either way is fine. So just jumping right ahead into the question, I have the volume and concentration of the acid, so I'm going to find the moles of acid. 0.0562 liters, and I'm going to times it by 0.25 moles per 1 liter. That's what this is telling me. So 0.0562 times 0.25 is 0.014141. I'll just round it off to that. That's your moles of H3PO4. Now we're being asked to find the moles per liter of magnesium hydroxide. So let's use the mole ratio to get from H3PO4, so moles of H3PO4 to moles of, sorry, I put it in the wrong spot. I can tell right away because it doesn't cancel. Try that again. We want to get moles of MgOH2. So moles of MgOH2, moles of H3PO4. And so looking at our reaction, the ratio is 3 to 2. So this takes the number of H's and OH's into account. So now, when we do that math, 0.1014 times 3, divide by 2, we get 0.021. And that's moles of MgOH2. And now we have that in 47 mils. So it's going to divide by 0.047 liters. So I take my answer, divide by 0.047. So I get 0.45 moles per liter of MgOH2. That's a point in there. And there's your final answer. So hopefully this helps you solve some neutralization problems.